Okay, everyone. Today sport technique manipulate our sequencing data, the FASTQ files. Uh, First, before we start with this demonstration, you need to DRAM, and then you need to have some disk space for the virtual machine setup. And then to set up the virtual machine, you need to have Oracle VirtualBox, Linux, uh, easy to use in your computer. And you need to understand some basic Linux command line in order to follow this demonstration. And of course, again, you need to have good internet connection. So first, I will show to you how are we going to check the integrity of the sequencing data downloaded from your sequencing service provider server. To check the integrity of the downloading data, we will use this command md5 sum. So we will log into our Ubuntu Linux terminal first. Here I have already changed directory into our working directory, sequencing underscore directory. Just type ls. I have prepared some sequencing data. I have prepared some sequencing data here, a FASTQ file, and then a pair n FASTQ file, and also .tar.gz FASTQ compressed file, to just show to you how are we going to check the integrity of the sequencing data, to show to you whether there is a loss of sequencing data. So first we'll use this samdata.tar.gz as our raw sequencing data provided by the sequencing service provider as an example to check the integrity. So to check the integrity of the sequencing data file, we need to calculate a MD5 sum value, of this particular raw data. So to calculate the MD5 sum value, you just type MD5 sum followed by the file, the sequencing data, the raw data file name. So here I use samdata.tar.gz as an example. So just type enter. So you will get a MD5 sum value in this manner, in this order. So after that, we compare to the MD5 sum value provided by the sequencing data service provider. So just type cat followed by the MD5 sum provided by the sequencing service provider. Now you can compare both MD5 value calculated by yourself and also the sequencing service provider. If the sequencing data have been downloaded completely and without any loss of data, so which means that the integrity of the sequencing data are guaranteed, you'll find that the MD5 sum value calculated by yourself and the MD5 sum value provided by the sequencing service provider will be identical. So if these two MD5 value MD sum 5 value are not identical, this means that somehow there is some loss of sequencing data when you are downloading it from the internet. It is not a it is not a complete data download from the sequencing service provider server. So this one you need to re-download again or check with the sequencing service provider. So I put the command line here in our PowerPoint slide. And then after that, you might want to perform some basic statistic analysis on your FASTQ file, the sequencing data. Here, to perform basic statistical analysis on your FASTQ file, I use this sequencing data file as an example. So the software that we are going to use is the SeqKit. SeqKit actually we have already downloaded and installed in our Ubuntu Linux on our previous demonstration on our previous video. SeqKit is actually installed using bioconda, so we can actually call the SeqKit directly from here to perform the analysis. So SeqKit stats. Now we are going to analyze this FASTQ file. SRR, this command you can either perform it on a FASTQ file or a compressed FASTQ file such as a .fq.gzip file. Here I already decompressed the this SRR .fastq, so I will directly use the .fastq file to show to you this command line how it is actually going to work. So just type enter SeqKit followed by steps followed by the sequencing data file that you wish to perform the basic statistical analysis. Just type enter. Okay. So using this SeqKit steps followed by the sequencing data file, and then we will put the result. We'll put the result in a text file named stats.txt. You can actually name any file name on the result. Here I just name it as stats.txt. So now we will see what is actually contained in stats.txt. So just type less dash dash s followed by stats.txt. So you can see that for this sequencing data file, uh, the SeqKit step already perform this analysis. It will inform you the format of your sequencing data file, and then what is the type of the sequencing read. Here of course is DNA, and then here the number of sequence you have. You have around 6 million reads, 6 million reads, 6 million seeded FASTQ reads in your sequencing data file here. And then a sum of the length of your sequencing data, and then the minimum length and average length, because this is actually a pair n 150 sequencing run. So the minimum length and the average length is actually 300 base pair. So maximum length is also 300 base pair. Here, because we have only one sequencing data file or only one FASTQ file, so you have only one line of the uh, result. Of course, if you have multiple FASTQ file, you can also use SeqKit stack to perform the basic uh, data analysis, the basic statistical analysis on your FASTQ file. So just type Q to exit, and then after that, you can also, using the same FASTQ file, you can also use another sequencing software. Uh, this one, the FASTQ. FASTQ, we are also using it. We are also install it using Bioconda, so we can directly call out FASTQ from our terminal. So you can use FASTQ to get the nucleotide composition and quality value distribution of every of your FASTQ read using this command line: FASTQ com followed by the sequencing data file name, and then put it on a com.txt. So just type FASTQ com followed by also srr.fastq and put it in com.txt. We'll wait for a while. It should be quite fast because we have only one FASTQ file. So after the FASTQ have already compute the composition of the every single FASTQ sequencing read in your sequencing data file. So we'll have a look on the com.txt. We put the result in this com.txt. So just type less dash s com.txt. But the result here, you can see that for every of your sequencing reads, they show to you this composition report. But the result here, they do not really show to you every column field names. For the column field names, you can refer to the PowerPoint slide here. I have already put the column field names here. This is the output format of FASTQ-com. So the first column should be the sequencing data identifier. Second column is the length, and then followed by the ASCGT composition and the ambiguous, two ambiguous space, three ambiguous space, four and ambiguous space, or N base, CPG, the transverse number, transition number, CPG and transition, and so on. This is how do we interpret the tabular format generated by FASTQ-com. Here we the explanation of the column field column field name. So this is the result of FASTQ-com. It gives you every ASCGT, the composition of the nucleotides in every of your sequencing reads. And then just type Q to exit. After we have generate the statistical report on every sequencing read for the sequencing nucleotide composition and the quality value. quality value distribution just now. Sorry, uh, let me have a look back on the. So this is actually the quality value as CGT. This is actually the quality value that you will have. So now we'll use another command. This one, seek FASTQ check to check the nucleotide composition and the quality value distribution on every position of your FASTQ read. This is just now we are checking the composition and quality value of every sequencing reads. Now we are checking the uh, nucleotide composition and the quality value distribution uh, on every position, which is position number one, position number two, position three, and so on until position number 150 or 300 uh, of the FASTQ reads. So just type seek FASTQ check, FQ check, seek FQ check, followed by the SRR again, this file again, and then we put the result in this document fqcheck.txt, and then press enter. So after we finish the run of seek FASTQ check, FQ check, we'll have a look on the result. Just type LESS dash S followed by FQ check dot txt. So you can see that this for every position of your sequencing reads, position number 1, 2, 3 until position number 300, it will show to you that the percentage of A, C, G, T nucleotides, and this is the uh, average quality value and the error rate quality value, and the low uh, quality value rates and the high quality value rates are all shown here. So this is the fast FQ check result for every position of your sequencing reads. So just type Q to exit. You can actually use the just now the FQ check result to plot a QC distribution diagram. You can use either Excel or other statistical diagram software to plot it using that tabular report. And then after that, if you have a pair n reads, read number one and read number two, in this case, you can use seek merge PE to combine the read 1 and read 2 into a single sequencing data file. To combine the file, we can use FASTQ merge PE. So just type here in the PowerPoint slide. We are going to use I edit a bit the PowerPoint slide. We are going to use SAM data dot one, the read number 1, and SAM data 2. We have a pair of pair sequencing data on our working directory. If we type ls, here we'll have samdata.1.fq and samdata.2.fq. So we'll have a pair of sequencing data here. So just combine these two sequencing data. But before we combine these two data, just have a look. LESS, that's SAM data .1 .fq. So this is the read number 1, FASTQ file read number 1, FASTQ file read number 2. Now we want to combine samdata.1.fastq and samdata.2.fastq into a single sequencing data file. So you can type FASTQ merge PE. We are going to merge these two pair and sequencing data into a single file. So samdata.1.fq followed by samdata.2.fq. We will merge these two sequencing data into a single sequencing data file, and we put it in merge pe.fq. So I can just type enter. So very fast. Just type LESS to see the outcome. Merge. Now you can see that we have already combined the two sequencing data file into one. But the way to combine the sequencing data file, the pair and reads by FASTQ merge PE is in this order. It will show to you the read number 1 followed by the read number 2, and then again read number 1 for another reads and read number 2 for the second reads, and so on. So it will show to you read number 1 first, and then followed by the read number 2 of the particular sequencing reads, and then so on. Read number 1, read number 2, read number 1, read number 2, read number 1, read number 2. So this is how do we actually combine the two pair and sequencing data into one single file using merge PE of FASTQ. So just type exit first. So this is how do we how some of the small techniques that we are using FASTQ or FASTQ to manipulate on our sequencing data FASTQ file. If you have a further inquiry or you would like to inquire about our service, do contact us at this email address, ngs.bioinformatics.123@gmail.com, or call us at this WhatsApp number. Thank you very much.